In the previous video we created a data frame called df with our mortality variables. Now we're going to introduce a new variable, GDP per capita, so we want to have some income variable in our data frame. And we're going to introduce this new variable in the data frame called df_n, where the n stands for new. So we do not call this data frame df because it would overwrite the data frame we have on mortality. So we give it a different name, dfn. And then later on at the end of this video we're going to merge df and dfn so that we have a new data frame which contains both the mortality variable and this variable on GDP per capita. Yeah, so if you go to the Eurostat website, you can see that the name of GDP per capita is this one over here. So that's the one we're going to download, but we're going to use lowercase, not uppercase letters. So you can get extra information by clicking on the plus sign over here. And the things we're going to be interested in is which indicator we're going to use, and we're going to use this, the first one, the B1GQ indicator. So you're going to see that in a second. Yeah, so here again, just as above, so the structure is exactly the same as we had above. So we get the data using this method getDataDF, so get the data into a data frame. This is the name of the variable. As above, we have this column geo/time, and to rename it we need to have two slashes. We're going to rename it geo. We're going to use this column geo, which contains the abbreviated names of countries, and then replace that abbreviation using the Eurostat dictionary into a new column called country. The GDP time series goes back all the way to 1975, but we don't need that because all the other variables don't go back that far. So actually going to drop a number of columns from 1975 to 2011. Yeah, so then again we're going to make selection. Structures again very similar to what we did above. So we want to have only the countries that are actually in the EU. We're going to choose this indicator here, which I just showed you on the website, the B1GQ. And we're going to use euros per head, per habitant. Then we can drop a number of columns that we no longer need. And if we run this cell, here we have the country, different country names, and here we have the time series, so the years 2011 all the way up to 2020. Yeah, but of course we want to have our years in rows, not in columns. So we're going to be using a melt statement as before. So let me show you how that's going to work. So we have dfn is going to be equal to pandas melt, and we're melting the data frame dfn. The ID variables in this case is actually only country. Yeah, so each row here is uniquely defined simply by country. So for each country we have such an observation. So then we need a comma. Then the value vars. So the values of the variables of the column names that we're going to be turning into rows are again these numbers. So there's going to be a numpy range starting at 2011 going to 2020, but not including 2021. Then the var name, so oops. Yeah, so when we put these numbers 2011, 2020 into rows, the name of that column is going to be year. Yeah, because these denote the different years. And the value name is going to be GDP per capita. Yeah, so just to check, dfn dot head. So what does it look like? So now we have country and year. Yeah, so that's now the unique definition of a row. So we have the GDP per capita of Austria in 2011, and it's given by this number. For Belgium, it's given by this number. Yeah, so that means now we have our GDP data, and the thing that we want to do is to combine this GDP data with the mortality data that we had before. And in order to do that, we're going to use pandas merge statement. So we're going to start from df, that's our data frame with mortality variables in it. So we're going to say that we want to merge this data frame with a new data frame called dfn. Then we're going to specify how we want to do this, and we want to do this on the left data frame, so that's df itself. That's not, so dfn is the right data frame, but we use df, which is the one on the left. So that means that all the rows that we have in the left data frame should also be in the final data frame. Yeah, if there are somehow more years or something, or more something in dfn, that's basically going to be dropped. Yes, you have different how methods. You have on the left, the right, you can take the intersection or the union, but here we do it on the left. And then we need to explain how we're going to do this, how we're going to do this merge. And on the left, we want this done on country and year. And actually, it's the same on the right. Yeah, so right on is also country and year. Yeah, so in our particular case, actually these columns have exactly the same names, but you know, in another context, these names might be different, and then we need to guide pandas to understand how to match the rows in this data frame to the rows in the data frame that we had with the mortality variables. So just to check then what the data frame looks like in the end. So our data frame is now country, so we have different countries for different years. So we have gender differences, but only for our mortality variables, so for preventable and treatable mortality, so these rows are different. But for GDP per capita, they're actually the same, because you know, GDP per capita for the country doesn't distinguish between male and female. Yeah, so that's why we cannot do the merge here on country, year and sex. Yeah, because there are no gender differences when it comes to GDP per capita. Yeah, so the merge here is done just on country and year and not on gender. Yeah, so now we keep on adding variables in the next videos. So, you know, once you get the idea, you don't need to watch all these videos. The procedure is the same in every of these videos. So we get the data, we get it into shape, and we merge it with the data frame that we already have.